In problem 31, we're being asked again, just like number 30, to write and graph an equation to represent the situation. Well, if I look at the information given, we're given basically 3 pieces of information, which is unusual in a linear application problem. We're given that meal plans, meal cards cost $20. Each meal card lasts 8 days, and so there are a few variables. We can go with dollar amount, we can go with number of cards, and we can go with number of days. I'm going to choose to just kind of forget about that information given, and I'm going to say we're going to let X be equal to the number of cards, and I'm going to let Y equal the number of days that this person can eat. And if if they buy 5 cards, that's going to cost $100. So we could go the dollar amount route, or we could go number of cards and number of days. But in a linear equation, you've got 2 variables. You've got an independent variable and a dependent variable. You can't have 3 in a linear equation. That being said, if X is the number of cards and Y is the number of days that this person can eat, or number of meals, is that what it says? 8 days. Each card lasts 8 days. So it said that each card lasts 8 days, and so if I have 1 card, then I've got 8 days. There's 1. If I don't have any cards, I don't have any days. I have 2 cards, that's 16 days. So we can see we have a linear situation going on, because we have a per day rate of change, meaning per card rate of change. It's 8 days per card. So if we have 8 days per card, that means that's the rate of change. That's the slope. Therefore, the slope is equal to 8. And the y-intercept we can see is 0, because if you don't have any cards, then you don't get to eat. So therefore, the equation of this line here is y equals slope times x plus the y-intercept. The y-intercept is 0, so we just have y equals 8x. So the number of days that you get to eat is 8 days times the number of cards that you have. And that's it. There's the graph, there's the equation, and we're done.